Okay, we've got our 12.4 notes. We're dealing with the probability of disjoint and overlapping events. So if you haven't already, make sure you've gone and printed out a copy of the notes. So you just have to fill in the examples and the notes there. Okay, we are actually going to start after the warm-up. You need a couple definitions, and then you're going to do the warm-up. So jump down to the bottom of the page. Down to the notes section. We've got pictures. We've got a picture of overlapping events, and we've got a picture of disjoint events. So overlapping events. Two events are overlapping when they have one or more outcome in common. So what does this mean? Events are anything we study that has a probability. So like when you roll a die, an event is considered getting a 6 would be an event, or getting an odd number is an event. So in this case, we're saying our probability experiment A has all the possibilities, all these events that are dots in circle A. Our event B has all these possibilities that are in circle B. And these four are in both. So they are what makes it an overlapping event, because both of those outcomes will fulfill either event A or event B. Now, disjoint events. Disjoint events are, we have two events are disjoint if what? It should be pretty easy to guess from the picture. We've got two events are disjoint if they have no outcomes in common. So let's say event A is rolling an odd number, event B is rolling an even number, and we're talking about rolling a die. There's no crossover between those things. You either roll an odd number or an even number. You can't roll a number that's going to be both. Okay, now let's jump back up to the warm-up section. So it says a six-sided die is rolled. Draw a Venn diagram that relates the two events. Then decide whether the events are disjoint or overlapping. So we're going to draw a Venn diagram just like down there in your notes. So our first problem here says we're going to roll a die, and we want to know when the result is an even number or the result is a prime number. Those are our two events. So first of all, we're going to make one circle in our Venn diagram for each event. I'm going to help you with this first one in the warm-up, and then I'm going to let you try the next one. So event A, we'll call that, draw a circle for your Venn diagram and label it with event A. So I just write even on my circle. And then draw another circle so that it overlaps, so you get a Venn diagram, and label that circle prime. Now think, is there anything that is both even and prime? 1, 2, 3, 4, 5, or 6. So 2 goes in both circles because it's even and prime. 3 and 5 just go in the prime circle because they are prime numbers. 4 and 6 go in the even circle. And then we even have to leave ourselves room to put a number outside of the circle. Now that you've seen this, are these two events disjoint or are they overlapping? Since one of the outcomes, specifically rolling a 2, satisfies both events, then they are overlapping. Okay, go ahead and pause the video and try the next one. All right, now we're back. Let's check your Venn diagram. So here's what our Venn diagram looks like. First one, event asked us to roll a 2 or a 4, so obviously 2 and 4 go in there. Second one asked us to roll an odd number, so 1, 3, or 5, and that leaves 6 outside. So there are no outcomes in both circles. So this is, what's the name? I forget the word. This is disjoint. Okay, moving on to the next section here. What I want you to do is for each of these sets of events, you're going to find the probability of A. Remember, that's the probability that event A happens just by itself. Then the probability that event B happens just by itself. Then the probability that A and B happen. That's saying if I roll the die one time, what's the chance that both those things happen on that one die roll? And then the probability of A or B. That's saying if I roll the die one time, what's the chance that at least one of those things happens? All right, I think you can try this on your own. So go ahead and pause the video, and when you come back, we will go through the answers. Okay, now we're back. Let's go through these one by one. Probability of A. What's the probability that the result is an even number when we roll the die? So there are 3 even numbers out of 6 possibilities. So probability is 1/2. Probability of B. What's the probability that we roll a prime number? Well, there are 3 prime numbers, 2, 3, or 5, out of 6 possibilities. So that's 3 out of 6, which is 1/2. Probability of A and B. So I'm going to look at my Venn diagram. That's the reason that I did this. And how do I get both of those things to happen? Well, it's only when I roll a 2. So that is 1 possibility out of the 6 numbers I could roll. And then finally, P of A or B. What's the probability that at least one of those 2 things happens? Well, the only way that either event didn't happen is if we rolled a 6. A 6 was the only one that doesn't fall under either category. So 5 times, 1, 2, 3, 4, or 5, are all going to give us either A or B happening. So 5 out of 6 times, we get A or B to happen. Okay, let's look at the next one. Remember, refer up to your Venn diagrams from the first 2 examples to help with these problems here. So probability of A. Probability we roll a 2 or a 4. Well, there's 2 good outcomes out of 6 possible outcomes. So that's 2 out of 6, which is 1 out of 3. Probability of B. Probability that we get an odd number. Well, that's 1, 3, or 5. So 3 outcomes out of 6, 1/2. Probability of A and B. I once again think this is easiest to look at my Venn diagram because I've already done the work. I see that there are no outcomes that satisfy both A and B. So that's 0 out of 6, which simplifies to be just 0. And then probability of A or B. So how many things total were in the table satisfied? How many dice rolls, I guess I should say, satisfied at least one of these 2 events? Well, that was everything except a 6. Oh, okay. In the last example, I misspoke. In the last example, it was everything but a 1. I was looking at the wrong table. This one's everything but a 6. So there, once again, are 5 total out of the 6 outcomes that satisfy either A or B. All right, let's go on to the notes here. So we've got some examples here. We've got to figure out, we're down on an example 1 now, we've got to figure out whether the event is overlapping or disjoint. So let's start here at number 1. So from the student body at Bishop Luers High School, all the students here, the question would be, what is the probability that a student is female or in the 10th grade? So let's think about that. Are those 2 separate things mutually exclusive? You can't be both. Or could you be female and in the 10th grade? Are there any outcomes? In this case, the outcomes are the students. Are there any students that are both female and in the 10th grade? Yes, there definitely are. So this is overlapping. Remember, right now we're not actually solving for this probability. We're just figuring out whether it's overlapping or disjoint. Okay, next one. When rolling a die, what is the probability that the number is even or the number is divisible by 3? Okay, let's go through. Number is even. That would be 2, 4, or 6. Number divisible by 3. On a die, that would be either 3 or 6. So you heard it right there. There was 6 in both of those categories. So that means that this is also overlapping. Finally, drawing a card out of a deck. Probability that the card is a heart or a diamond. Well, what you know about a deck of cards is there are 4 suits. Each card has 1 suit. So if a card's a heart, it's definitely not a diamond. If it's a diamond, it's not a heart. So these are disjoint. There are no cards that are both hearts and diamonds. All right, let's go on and learn some formulas. Okay, we've got 2 different formulas. We've got one formula to do the probability of overlapping events and one for the probability of disjoint events. So for overlapping events here, probability of A or B. So we're in this section, we're always going to be talking about or. We're not going to be talking about and, at least for our overall formula. So the probability that A or B happens when we've got overlapping events is probability of A plus probability of B minus probability of A and B. And you'll see how this works as soon as we get into using it. And then the probability of disjoint events, probability of A or B, is very similar. We just don't have to subtract the term at the end. So the way you can help to remember this is if we have overlapping events, when we do probability, we accidentally count that middle part twice, the part that overlaps. So that's why at the end, we subtract that part away. We subtract it away to account for the fact that we double counted it, and we don't want that to mess up our probability. Let's see how this gets applied. Okay, example 1 here. Card is or example 2 in your notes, I believe. Card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a 10 or a face card? So let's just think right away, see if we can figure out, is this going to be disjoint or is this going to be overlapping? A 10 or a face card? So is there anything I could pick that would satisfy both? Is there anything in a deck that is both a 10 and a face card? No, because all the 10s are 10s and the face cards are jacks, kings, and queens. So just to help us out, I'm going to show the Venn diagram here. As you can see, the circles do not overlap. So to find this probability of A or B. Now A, as you can see over here, stands for the event that the card is a 10. B stands for the event that the card is a face card. And here we're using, I guess I should write it, we're using disjoint events. Every problem, I think a good first step is to figure out, are we dealing with disjoint events or are we dealing with overlapping events? So with disjoint events, we know our formula is P of A or B equals P of A plus P of B. Pretty straightforward. So how do we solve this? What is the probability of A happening? What is the probability that we draw a 10? How many good outcomes are there when we're drawing out of 52 cards? Well, there's 4, because there's 4 10s. Out of a total, how many total outcomes? 52. So just like normal probability, just like we've been doing this whole time. So that's the probability of A. And then the probability of B. How many face cards could we draw? Well, there's 4 kings, 4 queens, 4 jacks. So that makes 12 face cards out of the total 52 cards. So I add these two together, and I get 16 out of 52, which simplifies to 4 out of 13. And if I want to convert this probability to a decimal, I could use my calculator and divide, and I get 0.308. So that's the probability that I either get a 10 or a face card. A little bit over 30%. Just have to choose which formula to use and then apply it. Let's go on. Same idea here. Example 3. We're still working with a deck of 52 playing cards. What's the probability that the card we draw is a face card or a spade? So let's think first of all, how many, are there any cards we could draw that would satisfy both? Are there any cards we could draw that would be both face cards and spades? Yes, we could draw the king of spades, for instance, would be a face card that is a spade. So let's look at what that Venn diagram would look like. So event A, drawing a face card, has all the kings, queens, and jacks in it. Event B, drawing a spade, has all the spades in it. But then I put those face cards that are spades, that are in both there, event A and B, in the overlapping section. So this is an overlapping event. So for an overlapping event, let's look back at our formula. P of A or B plus P of A plus P of B minus P of A and B. So pretty similar. To find the probability, I do the same thing, only now I have to subtract the probability of both happening. So let's figure these out. What's the probability of A? The probability of drawing a face card. We already talked about that. That's 12 out of 52. And the probability of drawing a spade, well, the deck is broken into 4 suits and evenly broken into 4 suits. So that means 13 of the cards are spades, ace through king. And then we need to subtract off the probability that I get both. So what's the probability that I get both? I can look at my Venn diagram and see that there are 3 outcomes that satisfy both. Or I could just think through it, how could I get a face card and a spade? Well, that would be the king of spades, the queen of spades, and the jack of spades. So that's 3 out of 52. Then I just add these all together, and I get 22 out of 52, which simplifies to 11 out of 26. Which if I want to convert that to a decimal, I can use my calculator and get about 0.4, whoops, about 0.423. So that's about a 42% chance that I'm going to draw a face card or a spade. All right, one more example. All right, example 4. Out of 200 students in a senior class, 113 of them are either varsity or on the honor roll. 74 are varsity, 51 are on the honor roll. What is the probability that a randomly selected student is both a varsity athlete and on the honor roll? So I want to point something out. This is different. It's asking for what is the probability that they're both a varsity athlete and on the honor roll. So just thinking about this situation, we're talking about whether students are varsity athletes and on the honor roll. Does this seem like it's going to be disjoint or overlapping? Are there any students who might be both a varsity athlete and on the honor roll? Yes, I do think that's possible. I sure hope so, at least. So this is overlapping. I'm going to write that here to remind myself. And then what we're going to do is we need to figure out all of the different, we're going to write the formula first of all. So P of A or B equals P of A. I'm using different colors for a reason here. Plus P of B minus P of A and B. Now I'm going to go through my text this time, and I'm going to figure out what given information I have. So I have 113 students are either varsity athletes or on the honor roll. Is that one of these things in the formula? Yes, that right there is my probability, or that's going to go in, tell me the probability for the part on the left side of the equal sign, the part in red, because that's the number who are either A or B. Okay, 74 seniors are varsity athletes. We'll call that A. So we'll say 74 are varsity athletes. I'll put that one in green. and 51 are on the honor roll. That's B. So that is the probability of B. And then the question is asking what is the probability that they're both a varsity athlete and on the honor roll. That's the one I have in black. So let's go ahead and just plug things in. So the 113 are either, that means that's the or, they're either A or B. So that's 113 out of how many? Out of 200. Okay, and then equals probability of A. So A is that they're a varsity athlete. We've got 74 out of how many? 200 still. And then plus probability of B is 51 out of 200 again. And then this final part is what we're solving for here. P of A and, whoops, get out of here. P of A and B. So we're not always just going to be solving for the left side of this equation. Sometimes we might be solving for something different. So now let's go ahead and rearrange some of these terms. Let me get some more space over here. Okay. So I'm going to add the P of A and B over to this side. I'm going to do plus P of A and B. And then I'm going to subtract the 113 over 200 over to the other side. So 74 over 200 is 51 over 200 minus 113 over 200. Okay, now all I have to do is just combine all of these fractions. So I add them up and I subtract the 113 and I get 12 out of 200, which simplifies to be 3 out of 50, which if I convert that to a decimal, actually I don't even need to put the squiggly signs there. The squiggly signs mean about. This one actually converts exactly to 0.06. So about 6%, so actually exactly 6% of our students are both varsity athletes and on the honor roll. I would expect that number to be higher, maybe somewhere else like here at Luhrs. All right, that's the end of the notes. Now you go ahead and do the practice. Good luck.